everybody! So, before you dive into the world of statistics, you need to know two concepts. The first concept is sample space. Sample space is a list of all the possible outcomes in an experiment. For example, I have this cup of popsicle sticks with popsicle sticks and then that have the numbers 1 through 6. Now, your sample space in this experiment would be stick 1, stick 2, stick 3, stick 4, stick 5, and stick 6. That, ladies and gentlemen, is your sample space in this problem. And now, if you had a blocks with the letters A through D on them in a bag and you had to pick one, your sample space would be block A, block B, block C, and block D. That's another example of sample space. And that is the first concept. All right, I'm done. I have a bunch of candy canes, all striped. And now if I pull out a candy cane, each candy cane has an equal chance of being chosen, and I am unbiased. So this makes it a random sample. I pulled out this candy cane, random sample.
Okay, today students, we are going to be learning about the addition rule. Okay, I have this problem here for you, Angelica. Here's your whiteboard. You're going to be working on it. Okay, in a group of 60 students, there are 36 juniors, 20 female, and 13 female juniors. Okay, find the probability that a student picked from the group is either a female or a junior.
So
Okay, first we're going to need the addition rule equation. Okay, so you're going to put probability of A or B.
Is A this one or that one? And
It's this one. It's or. This is the one that goes up. It's equal to the probability of A plus the probability of B minus the probability of A and B.
Probability of A
Or B
or B is equal
is equal to the probability of A plus the probability of B minus the probability of A and B.
Is it like this?
Yes.
It is like this. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. I will be using this equation to solve this problem.
Okay, so we know that there is 36 juniors, so we're going to put juniors. It's 36 over 60. Okay, and we know that they are the female. 20 over 60, and we know that there are juniors and female are 13 over 60. Okay, so you're gonna plug this into the equation. Okay, your first one is 36 over 60 minus 20 over 60 gives you, that is 16 over 60 minus 13 over 60.
So that would be 3
over 60. And that's your final answer. So the probability that a female or a junior gets picked is 3 over 60.
So the probability that it will be a female junior is 3 out of 60.
Female junior.
Oh my goodness, I have learned so much. Thank you.
Okay, so today I'm going to be talking to you about exponential distribution. So here we'll have the example of getting a heads on the 5th try. You'll be plugging in all your numbers into this formula. So here I have T, which is time, your time of trials, which is 1. It's your first trial. So you have your 1. T equals Q, which is 0.5, or 1/2 of getting either heads or tails. And then you have your minus, you have your A minus 1, which is A, you plug in your number of trials, minus 1, times P, which is your 0.5. And then you would solve your solution, and it would be 0.5 over the 0 point times 0.5, and then you would get 0. So that is your very first point for your exponential distribution for your graph. And then once you have all your full trials till you reach 5, you will plot your points, and this is how it will look.
Oh, hi. Didn't see you there. I was doing some stats homework. I'm going to be explaining today tree diagrams. It's pretty interesting why would they use it. It's to simplify, and it's also another way to show your probability solution. So come on, follow me. So you can see like this tree. Every branch represents the different possible outcomes of the probability. So you can see this tree has a lot of different probability outcomes. Now, I'm going to give you guys an example on my whiteboard. Oh no, how could I forget the pen? There, much better. Today, I'm going to be showing you guys how to use a tree diagram for spinners. Well, instead of using one, we're going to be using two. It's more challenging. So, what you're going to do is take the first spinner and write down all the numbers. So the first spinner contains 1, 2, 3, and 4. Second spinner contains 5, 6, 7, and 8. So you take the numbers up for the first spinner, which is 1, 2, 3, and 4. Then you make branches for all the other ones. So there's 4 numbers in the second spinner. So 1, 2, 3, 4. So you're gonna plug in the numbers, 5, 6, 7, and 8. You continue on doing it for all of them. Boom, voila. Now you're going to take them and go across. So the first number is 1, second number is 5. So it's gonna be 1, 5. And you keep on doing it through all of them. So 1, the next number is 6. It'll be 1, 6. And then you do it to all of them. Voila. So once you have all of them, now you can work onto your probability. So let me give you an example. So what's the probability of getting that you get 5? That's better. Okay. Now you'll see that there's only a 1 in 5. So therefore you're gonna have 1 out of 16. There's 16 different combinations. Now let's look at what's the probability of not getting 1 out of 5. So what you would have to do, so you will get 15 over 16. That's the probability of not getting 1 and a 5. 1, 5. Pause. And that's a tree diagram.
And that is the first concept. All right, I'm done. That's it. Good. Oh no, it's too big. I must rewrite it. Can you please repeat the equation? Okay, sorry.
Action.
So that there are 60 students in total.
So where would my 60 go in this equation, teacher?
Action.
Go? Really? Is it going?
Sorry.
Oh my god. Okay, so today I'm going to be talking to you about exponential distribution. Say for example we have a coin flip and the chances of getting it heads on the 5th flip. So we have a formula here which is parentheses A, T stands for trail times, Q stands for the Q and the P.
Oh my gosh.
Oh, it's going good.
Way to
though.
go, you killed it.
Yeah. Dude. Okay, hold on.
First stats and it's also from our video class. Chill.
Should I not even like mention like everything that's done for the formula?
You need to. Probability. Q is for
I don't know. I can be like, which you use the formula parentheses AT, which stands for Charles, equals Q A to the minus 1 times P, and then you, yeah, I can do that. Just? Okay, start it over. I got it.
Oh shoot, it's still recording. It's not good.
Yeah.
A 1 and then a 4. So you'll look at it and you can only see that there's a 1 and a 5 is take a 1 and then minus it from 1 over 9. Then you'll get 8 over 9 because wait, plus.